So hi everyone, welcome everyone to the fourth episode of the Mapping Urban AI webinar series. I'm Alexandra Vidal. I'm a researcher at CIDOB and I will be moderating today's episode. So before introducing the topic and the speakers that will be joining us, I will first explain to you where this series comes from and the background of the organization behind it, in case this is your first episode of the series. So the Mapping Urban AI series is a webinar series on how cities design, use, and implement urban artificial intelligence for different purposes. So from urban health to sustainable efforts. It is co-organized on one side by Urban AI, a French think tank specialized on urban artificial intelligence, and CIDOB, the Barcelona Center for International Affairs, which I represent today. CIDOB is a think tank also based in Barcelona. It's specialized in international relations. And since 2018, it counts with the Global Cities Program, which researches on global cities and international relations. And within this program, there's several lines of research, one on socioeconomic challenges, which features also the digitalization efforts of cities throughout the globe. Here we have a joint project called the Global Observatory of Urban Artificial Intelligence, GUI in short, between CIDOB, the Global Network Cities Coalition for Digital Rights, and the cities of Barcelona, London, and Amsterdam. So GUI researches and monitors urban AI initiatives that align specifically with certain ethical principles, such as transparency and openness, fairness and non-discrimination, privacy protection, cybersecurity, accountability, and sustainability. We also wanted to share with you GUI's flagship project, the Atlas of Urban AI. I'm gonna share with you my screen so you can see it for yourselves. There we are. So this project basically monitors urban AI initiatives in cities throughout the globe that aligns with the ethical principles that I already mentioned. Right now we have 150 cities initiatives, and 55 cities. It's for public consultation, so any of you can enter and even like share initiatives if you know of. We're open to any recommendations, basically. Give me a second. We will share with you the link, of course, so you can check it out whenever you want. And now that we presented ourselves, let's get started on today's episode on AI for sustainable cities. So today we count with Elli and Jan from the Barcelona Supercomputing Center, which is the national supercomputing center here in Spain. The center specializes in high performance computing, and they also manage Mare Nostrum, which is one of the most powerful supercomputing centers in Europe. Elli is a researcher on computer sciences, and Jan is a researcher on earth sciences. And they will explain to you today how AI can be used to monitor traffic-related air quality in cities. So thank you very much, both of you, for joining us today. And basically, the floor is all yours.
Thank you very much, Alex, for the presentation, and welcome everybody, and good afternoon. So let's share the screen. Yeah. So in principle, are you seeing already presentation?
We are.
Perfect. So let's start. So we both work at the Barcelona Supercomputing Center. As Alex said, I work more in the earth science department, and Elli works in the computer science. So I will be introducing like the problem and the background of our solution, and then Elli will develop on the methods and the technology that we are using for this project. So let's go. So the World Health Organization stands that actually air pollution is the main environmental threat to public health. And it is known that we are widely exposed to toxic pollutants around the world, but especially in cities. And Barcelona is no exception. Actually, we rank as the 6th European city with the worst mortality associated with NO2. And if we see historical data of NO2 in Barcelona, we see that we largely exceed the 10 micrograms per cubic meter limit of the World Health Organization, largely. And then we are at the edge of also exceeding the limit of the European Commission, so the legal limit. So we know that we have a problem. So the first step to tackle this problem is to understand it and to monitor what is the quality of the air we breathe. And for this, we know that actually the reality of the air quality in a city is quite complex. The first approach that we have are what are called the air quality monitoring stations. In Barcelona, we have more or less 10 stations that give like precise information on the concentration levels of the pollutants. And they do this in an hourly scale. So this information is crucial, I would say. The problem is that we don't really know what is going on among the stations. So we know the information at a specific point, but there are a lot of people living here and we don't know what is the air quality. That's why the so-called regional models or mesoscale models already give us the information covering all the space with full coverage. And this is really important because we really get this information. The problem is if we draw a line across the city and we look at the concentration along this line, we'll see that there are peaks of NO2 of high concentration levels close to traffic streets. And the thing is that the regional model is not able to capture these strong gradients of pollutants because, for example, this model has a resolution of 1 kilometer, which is not enough. That is why we need urban models. And today I'm presenting here the Calliope Urban, which is an multi-scale air quality system that has two main components. So the first one is a regional model that accounts for the long-range transport of NO2. And for this, we use nested domains at increasing resolutions. And then we have our urban model that is really able to capture these strong gradients close to the streets. And I have here, a simulation. Here in green, you see concentrations of NO2, the north of Europe, and here in Italy, they also have a problem. And this is at 4 kilometer resolution Iberian Peninsula. And this is, as I was explaining, the domain for Catalonia at 1 kilometer resolution. So all this information is plugged in this urban model that is really able to capture this spatial distribution. And yeah, the urban model gives us the information of how these pollutants from the vehicles disperse at the street scale. So why we need this? Why is important that today we are speaking about this and how this interact with artificial intelligence? Because this kind of models has three main applications that I will briefly develop here, and then we will go to the artificial intelligence part. So the first application is the forecast. So it is important to early warn vulnerable parts of the society that really suffers from pollutant episodes. For this, the Barcelona Supercomputing Center has an operational model that produces daily forecasts of the air quality, regional, but also urban. Then this is an application. Another application is for urban planning. If you want to know in advance what will be the effects of a certain traffic measure, you first have to really well define how this measure works. Then you have to put this information in a traffic model to compute how traffic will redistribute. Then this information goes to an emission model, and the emissions go to an air quality that can really assess how this measure will impact on air quality. And the third application is the health impact assessment, for which we take all the historical data on air quality and we cross it with health data. And this is to understand what actually are the effects of air pollution on public health. So let me briefly explain you how this model works so we can understand what AI can do here. Okay, so this dotted line refers to the regional model, the mesoscale model, that has three main parts. The first one is the meteorological model that give us information like wind speed, precipitation, so on and so forth. Then we have the CMAC model, which is the chemical transport model that will compute how these pollutants disperse and how they interact among them with the chemistry, okay? And the final part is this one, which are the emissions, which for the urban application, so this is the regional model, and all this information will go to the Gaussian dispersion model in order to obtain our fields of concentration at the street scale. The problem here, on one of the problems of one of the uncertainty sources is the emissions, because in an urban environment, the emissions are really difficult to characterize because there are like many vehicles, and it's really difficult to estimate how these vehicles will move. We can have like a gross estimate, but to have like really well defined these emissions is really complicated. So here, exactly in this point, is where our project is doing a contribution based on AI technology. And now is the time that I give floor to my colleague here, Elli, that will explain more details on how we're doing this. Thank you very much.
Okay, thanks, Jan. I think you made a great introduction about the need to better estimate air quality. So I will explain a bit the context of this program, this project. So it's called Air Urban because it stands for IoT and AI-enabled digital transition towards clean and safe urban mobility. So this is a national Spanish-funded project funded by the Spanish government and also the Next Generation funds from the European Commission. And it is a project in the line of a call for projects for the digital and ecological transition. So this project, as we already said, is executed by us in Barcelona Supercomputing Center, and it is a multidisciplinary work between our two groups, one that handles the part of the computation and how to improve performance and be able to efficiently execute complex AI workflows in order to obtain results in real time and near real time. And then we have the part of the air quality modeling and forecasting that leverages this information to improve the air quality forecasting. And we also have the support of two public entities, the Institut Municipal de Informática, that is part of the Barcelona City Hall, and Generalitat de Catalunya. And they both provide some support for the pilots that we want to implement in this project, since we want to implement some pilots at street level. And we also want to leverage monitor data from air quality monitoring stations that are available in Catalonia, in Barcelona. So what is the main concept behind this project? Well, this project is based in the concept of smart city. And by the term smart city, we understand an intelligent and connected environment when we may have a large number of data sources that are now under the hot keyword IoT, that is Internet of Things. So we have a lot of data that we can leverage. So what kind of data can we consider in these traffic-centered scenarios? For example, here we can think about some sensors that are available at the infrastructure level of the city. So for example, we may have traffic cameras that monitoring part of the street and capture the traffic that circulates there in real time. We can have information about the traffic lights, and we could also have information about weather condition, temperature, wind speed, and also air quality, for example. In addition to this, now we have a lot of connected vehicles that could also contribute by transmitting additional information such as their position, their speed, etc. And this can also apply to vehicles, to private vehicles, but also to public transportation. And in the end, we also have our smartphone, because we as civilians also are connected, and we could also provide information about our position in the city, and then we could also receive information and receive useful applications. So this is a huge amount of data that can be generated, but the key here is that we need to apply artificial intelligence and big data technologies in order to transform this data into valuable knowledge and generate the real value is to be able to generate applications that have an impact on our life and our society. So this is where artificial intelligence enters into play. So here in BSc, in our group, we are working on 2 parallel projects that are leveraging the same type of infrastructure and the same type of technologies in order to have 2 very different applications. One is about safety that I just mentioned here. So here, the idea is, for example, to capture hazardous events that happen in the city and generate alarms that can help us mitigate and the possibility of having a traffic accident. For example, here, you can see a person crossing the street when the tram is very close. And then the second project leverages this data here in order to understand the traffic condition and insert relevant data to air quality modeling. So this is the air urban that we'll present in continuation. So what are the objectives of air urban? Well, in this project, of course, we focus around air quality forecasting, and we have defined 3 specific objectives. The first one is to enhance the air quality forecasting by considering real traffic information into the emission models. So as Jan previously presented, at this moment, basically they are using traffic models in order to understand how the traffic in a city takes place and have some estimation on the amount of vehicular emissions that affect the air quality forecasting. So in this project, we will try to derive the real characterization of traffic by installing cameras that are able to, through artificial intelligence processing, we are able to detect the type of vehicles, their speed, acceleration, and any other useful data that can be fed into the emission model. So here we can have a real estimation of the traffic in different parts of the city. The second objective is to assess the impact of traffic events on air quality. So in addition to estimating the emissions by a more reliable method, we want to understand how specific traffic events that take place in the city are correlated with the air quality. And what do we mean with these traffic events? For example, we may have a touristic bus that stops to unload a lot of people, or trucks that stop in a loading and unloading area and stay there with their engines on for a lot of time, or have specific congestion events that may have an impact on air quality. So how can we estimate this impact? Well, in this project, what we aim to do is to correlate this data, this event detection that comes from the data sources and the AI workflow with actual measurements that are provided by Generalitat de Catalunya from specific measurement stations that are installed in Barcelona. So we want to find if there is a specific correlation, for example, if specific congestion events happen in the city, what is the impact on the measured air quality? And this type of correlations can help us to improve urban policies. For example, if we understand that specific events have a negative impact of air quality, we can take the necessary measurements at the city organization level. And then the third objective is to go one step further and try to estimate the real-time air quality levels based only on real-time traffic data. So there the idea is to train a deep neural network that will have as an input the output of the artificial intelligence workflow here, so that the real detected traffic conditions, and it will be calibrated with data from their quality monitoring stations. So the ultimate goal of this is, once we train this model, to be able to estimate the real-time air quality levels based on the traffic we observe, without having the need to have inputs from the air quality measurement stations. And if we manage to do this, the impact could be significant because we would be able to use the cameras as an additional sensor and an additional monitoring station. So instead of having to install these big measuring stations in fixed locations in the city, we can have additional cameras that complement the view that we have from the city. So these are the three key objectives in our project. We have just started, so we hopefully get there. So what are the key enabling technologies that allow us to have this type of processing and computation? So first of all, we have IoT. So as I already explained, we have a lot of sensors that come from the city infrastructure, the vehicles, and also the citizen engagement. But here the challenge is that these are a lot of distributed sources that generate huge data volumes. So traditionally, this computation used to take place at the cloud. The problem is that if we transfer all this data to the cloud, first, this has a huge impact on latency, on energy efficiency, because it takes we waste a lot of power to transfer the data to the cloud. And there are also security and ethical constraints. Because, for example, think if you have to transfer all this video from the camera feeds to the cloud, to the central location. The emerging technology that deals with this type of challenges is known as edge computing. So the main idea behind edge computing is that instead of centralizing all this information to a remote cloud, we bring the computation closer to the data sources. So there, the idea is to place some computing nodes close to the cameras, do the first level of processing there, and then only be able to handle the metadata, for example, the type of vehicles, their speed, etc., and only deal with this anonymized data and transfer them to the cloud, and where we implement the data models. So the advantages are the reduced latency, energy efficiency, and also this type of security, because we don't need the actual video feeds, for example. The challenge here is that there are a lot of heterogeneous architecture at the edge. It's not a closed technology. So we have to deal with high heterogeneity in the type of computing nodes, etc. Another level of heterogeneity comes from the communications. So the communication technologies are needed in order to interconnect all this type of infrastructure, both the data sensors and the computing infrastructure. So communications provides this ubiquitous connectivity, the connection between the edge and the cloud and the end users. But again, there is high heterogeneity in the technologies. And finally, the last piece of this puzzle is the use of AI and big data technologies. So their strength and their necessity is that they allow us to transform this huge amount of data into valuable and actionable knowledge, and they can be adapted to the different use cases. So just as I presented before, we have two different analytic pipelines that use the same data for two different applications. So we can have different applications, different type of knowledge from the same huge amount of data. And here the complexity is that how do we execute efficiently these heavy computational processes? Now, to better understand what type of analytics we are talking about, here you can see a very simplified example of our key pipeline. So we have the frames from the camera. We apply an object detection method. So we are able to detect the different types of vehicles and road users and pedestrians that are marked here as bounding boxes. Then we perform object tracking, where we follow the users as they move in consecutive frames. So here we use some kind of filtering in order to understand that this person here, for example, is the same person that has moved through this trajectory. In case we have more cameras that cover the same area, we apply a process that is known as the duplication. So for example, if you have these two cameras, we see that there is an overlapping area here. So here the cars, for example, detected in this area will be detected twice. So with this process, we remove the doubles and we only keep the best detected version of the vehicle that will probably come from this camera that is closer. And then we apply semantics that enable us to detect specific events. So the semantics will depend on the exact events and type of incidents that we want to capture. For example, here, if we specify the zebra crossings, the truck area, etc., we can understand when a person is on these specific areas. We can understand if a vehicle is stopped here, etc. So depending on the type of events that we want to detect, we apply specific semantics and specific rules. So when we have all this information, we are able then to extract the knowledge that we desire. For example, for this use case, we are interested in the type of vehicles, for example, if it's a car, if it's a motorcycle, if it is a truck, etc., their speed, their acceleration, and the different events that we will define within the project. So this is the type of AI analytics that we are interested in order to be able to extract the information needed to fit the emission model and eventually the air quality forecast models. Now, from the perspective of computation, the challenge is that these functions here have some complexity. And the issue is that these functions are also applied to each video frame that we capture. So if we have multiple frames, that is a normal thing to happen. If we have a live video stream, there are a lot of functions that need to be executed one after the other. And if we have multiple cameras, the amount of computation is also very high. So what we do in BSE is that we try to optimize this execution in order to have some real-time responses. Now, this is a small example of this workflow. So here we can see that we have some estimation of the speed. For example, this car goes with 40 kilometers per hour. And the challenge here that we are currently working on is to validate these measurements and calibrate them and also determine their uncertainty, because the uncertainty in the estimation of the vehicle speed is also propagated through the emission model and eventually the air quality model. So this is a work that we try to jointly do with Jan here. So let's see. Yeah. So just briefly explaining our technical contribution in this project is that we try to facilitate the development, deployment, and execution of this type of innovative application and services, and enable their execution anywhere across this edge and cloud compute continuum. So with this term, we mean anywhere, wherever we have computational resources. So we want to make applications that are, we want to abstract the way we write the application from the underlying infrastructure in order to have this application running wherever we have available computational capacity. And then we want to make this unified computing and communication ecosystem so we can run parts of the application. If we have some real-time components, run them closer to where the data sources are. If we have some heavy computational models, for example, for the air quality forecasting, they can be run to the cloud or the HPC, the Mare Nostrum facility. And we want to make this in a unified way. And finally, we want to be able to monitor the execution of this pipeline and be able to adapt to changes, scale out some functions if some computing nodes are congested, or migrate some functions to other resources. So this is the technical contribution of this project, apart from the scientific contributions in the improvement of the air quality forecasting. So in this project, we are considering 3 pilot locations because we want to try to do a real-life demonstration. We have identified 3 candidate locations that are strategically selected where there are existing air quality monitoring stations. So 2 of them in Eixample and Gracia are close to air quality monitoring stations that are specialized in traffic. And then the 3rd location, Poblenou, measures the background emissions. Concentration.
Urban background.
So our plan is to install a number of cameras here in order to capture the traffic around these air quality monitoring stations. And then we will be able to contrast and validate the estimations we have from our models with the actual data that is measured in these air quality monitoring stations. So I think that's all. So concluding, we have seen how we leverage artificial intelligence, earth computing, and all this methodology for air quality forecasting to enable the digital and ecological transition. So we want to be able to transform the city, the data coming from the city, into knowledge for smarter and sustainable environments. We showed how we try to improve the air quality forecast from both a macroscopic and microscopic perspective. And with this, I mean, we consider different time scales for the air quality modeling that goes from the macroscopic model from hourly averages and the microscopic modeling up to few minutes that come from the estimation of the emissions from the real traffic feeds. And finally, we show how this kind of correlation between the traffic and the air quality can lead to the implementation of effective mobility policies and urban planning. So that's all from our side. If you want to, you can follow the links of our two ongoing projects in LinkedIn. So that's all. Feel free to ask any questions.
Thank you very much, both of you, Elli and Jan. That was a super interesting presentation. You can actually share the links if you want through the chat, so it's easier for anyone to access. And I mean, now the floor is open for anyone that wants to ask any questions. I see already 2 questions there. I'm gonna go ahead first and ask one that I'm very curious about. I was wondering if I understood correctly, you're gonna measure only like traffic related to vehicles such as trucks or cars, etc. But is there an idea of expanding this to portuary transport, for example, in the case of Barcelona?
Well,
That's just
That's interesting. Well, for the case of Barcelona, we know that most of the NO2 pollution in generally speaking, across the city, it comes from vehicles. So this is the main source that it makes sense that we start focusing on this source. But it's true that it's also interesting to apply this kind of technologies on. But it's true also that for boats, it's more predictable. I mean, it's more, because there are not as many as cars, and they are all GPS. They are all GPS controlled. So I think maybe, yeah.
Okay, that's amazing.
It's a good input. Thank you.
You're welcome. I will go ahead and ask Hoover's question next. He said, do you envision to give access to the information produced by this model to people through another medium than your open data portal? For example, digital apps, urban physical interfaces, etc. It's in the chat.
You mean the air pollution fields or the output of the?
I think he means the information produced in general, like, I don't know, the map of where the air quality is better or worse in the city.
You can share the web page.
Have to. Well,
maybe we can share the screen.
We are already sharing through Calliope at BSC. We are already sharing the information at the regional scale, and we are planning to open the urban model next month, actually.
That's great.
Yeah.
He specifically asks if you're gonna also share it not only through this portal, but like through apps, for example, that you could have on your phone or something like that.
Well, so far this is a small project. Air Urban is a national project that lasts 2 years and has a very limited budget, but ideally, yes, I think it would make sense to have this type of services that engage civilians. So when I mentioned the data sources, for example, our smartphones can be the source of data, but can also be the end user that receives the data, that receives the output of all this calculation. So probably not within Air Urban, but eventually it would make sense to channel this kind of innovations to real applications. I'm not sure.
Yeah, that's great.
The screen if you want to show.
We're seeing your screen actually. Still. Aya, Moana, I see you have like your hand raised. You can go ahead and just ask the question yourself.
Yeah, hi. Thank you so much for this presentation. Hi, I'm Aya Mohanna, and I'm an urban resilience specialist from UNDP. Very appreciative of this presentation and about the potential of urban AI in informing better planning. My question, well, first, can we go back to the presentation? There is something I wanted to note down, but you guys were quite fast. It's the slide with forecasts, and then there was the scenario thing, and then the health application.
Yeah.
Could we go back to that structural slide? Right. Just a sec. Okay, so it's actually about this specific slide because I was specifically interested in the scenario planning component.
The scenario.
As
Yeah.
I understood, there's a simulation aspect to it. So ahead of applying any revisions for traffic models, you can simulate this through this app and then, well, not app, but simulate this through computation and then predict air pollution, basically, or its effect on air quality, right?
Exactly.
Okay, so what is the extent of the simulation? Is it just about redirecting traffic, or is there space? And I'm very aware that this project is quite young and still starting off, but is there any space to also account for example, if a one-story building is demolished and then there's a tower that is built in its place? So obviously there will be more traffic. Is it also, does this simulation account for developments and increased density or increased occupation of the urban space? And also, does it account for example, if we stop vehicles here through a new public transportation scheme, does that also account for it? So I'm just wondering, what is the extent of the simulation? Thanks. And thank you so much for the presentation. It's really interesting.
Thank you for your question also. And I would say that for the moment, what we have done so far here in the BSc, it only deals with the traffic model. So what we have done actually is there are some measures that the City Hall is planning to apply here in Barcelona. And we have actually a paper, a recent paper that I can share with you, that we have simulated through a traffic model, because when you cut a street, it's not like the cars will just evaporate, but you have to understand how the traffic will redistribute. And regarding your question about if you change the morphology of the city, we also account for this in our model. So theoretically we could apply also changes in the morphology of the buildings, but for the moment this is static information. We really don't not touch this, but yeah, sure. I mean it affects, but I don't think like it's a driving, I mean the morphology, but it surely affects. Yeah. I don't know if I answered.
Yeah, thanks a lot. No, you absolutely did. Thanks a lot. Can I actually leave my email for you to send me that paper, because
sure.
I'd be interested to read. Thanks.
Sure.
Thanks a lot.
Actually,
right. If any of you actually want to contact like the speakers, you can just contact CIDOB and we will put you in contact all together. There's another question from Mani Dingra. I really hope I'm pronouncing your name right. How do you deal with data privacy and ethical issues such as capturing cars, registration numbers, and people's movements? I think you already kind of covered that, Elli.
So again, this is a research project, not a final prototype, because if we were in the position of providing a service to the city, we have to be much more careful about this. So for this specific project, we just want to capture anonymized data on the vehicles, types and movements. And when we say type, we mean type of car, truck, this kind of abstraction. And we don't register plates. So we don't, I mean, the cameras will be placed at the top angle. They will not be focused at the plate level. So maybe some plate could be visible if you go and zoom in the video, but it's not detected by our object detection algorithms. And the key idea here is that when this is operational, it would not transfer the data, the video data, anywhere. It would not have a recording of the video data. It would just feed this live video stream to the input of the analytics, and we would only have access to the output, which would be a data set of this type of vehicles with this type of speed, etc. And the detected person crossing the street, for example. It would not have visual snapshots of the people or the vehicles. Of course, if cameras are installed in the city level, you need to have specific guarantees that videos will not be recorded and transferred by people that are not authorized. Now, regarding the plates, this was one application that we considered that would be very useful to be able to detect the plates and consult some registry about the specific type of vehicle. Because for the air quality, the vehicle emission modeling, it is very important. It would be much better to have the specific type of vehicle, because then we could consult the exact type of emissions that they have. If it's an older vehicle, it would have a different emission pattern than a newer vehicle. If it's an electric vehicle, of course. So part of this can be detected by the video camera, but not really. So if we would be able to detect the license plates and consult some registry, we would have specific information about the type of vehicles. But this has a lot of ethical constraints, so it's not contemplated within this project. If this was a service, it would have to be handled also by the police and the government to have this level of security.
Great. I will go on and ask this next question from Shruti Sidhu. How were those 3 sites selected? Gracia, Champla, Boulogne. Any specific credentials for selection?
Well, the key motivation is that in these places, there are already installed these air quality monitoring stations. So this, I think in one picture, you could, here. Wait. They look like this.
So in Barcelona, there are only 2 sites measuring locations representative of traffic, which are Gracia and Eixample. So they are the only ones. And then we select an urban background to have another, to see to what extent we can extrapolate this, not only to traffic station, but also to urban background stations.
There was also a possibility of having mobile air quality monitoring stations. So we need to see if this is a possibility, then with the coordination with the Generalitat de Catalunya, we could have a mobile station that it's actually a van with the sensors on top, parked in a specific location, and measure the air quality in that specific location. But we really need to correlate the input from the cameras with the measurements from the stations. So for sure, the fixed stations are there, they are operative, and we have access to the data. So the safest option is to monitor these specific blocks of the city.
So in summary, it was not a choice. There were the only 2 traffic stations in Barcelona.
Good. Then Marta Galceran, who's also from CIDOB, is asking how easy it would be to replicate this project on other cities. And to what extent do you think that projects aimed at monitoring quality of air are only for cities in the global north? Because you need many data collecting points, as you were talking about, and this is expensive, of course. So that's the question.
Well, for the first question, we have had some first, well, the idea of this project occurred because we had the first smaller pilot of this concept tested in the city of Modena in Italy. So the technology is the same. Back then, we had just a very limited application, only considering the emissions and not their quality. And the main problem that we were facing is that we didn't have any data to contrast it. So we were calculating some emission levels, but we couldn't know if they were true or false. We had no idea no way to validate this data. So the key part of this project is not the artificial intelligence part is similar, it will be enhanced, etc. But the key idea here is to contrast this data with the actual measurements that come from their quality monitoring stations. So this will help us to understand if we really have estimations that make sense and not generating some numbers there that are uncertain. And then about the other part, I think depending on the type of environment, I mean, we were presenting this project in the Smart City World Congress, and we had a delegation from Chile, I think.
Don't remember.
That they were very, very interested in this kind of, also from Brazil, they were very interested in this kind of solutions, but they mentioned that the main problem there is that the cameras were not safe. People were stealing the infrastructure. So I think this is the first issue. To be able to have a smart city, you need to have some infrastructure that is in place. Regarding the cost, well, the thing here is that the cameras, you don't need to have smart cameras. We just have simple cameras collecting data. And you could extrapolate. Also, for example, you could use existing cameras that are monitoring the traffic that are installed by the police or the city, so city TVs. So you could leverage existing cameras that are there and apply this processing.
Yeah, this is an interesting point. I think that if it works, this project, and it really gives, so we are able to validate this workflow through the measurements, as Elli was explaining. I think it can has really impact because there are a lot of cameras already installed in cities. So we could take advantage of these already installed cameras. So I think it has a lot of potential. Let's see.
Let's see indeed. Then we've got Marina, who actually asked if you can share the slides afterwards. I'm not sure if you can do it through the chat, but like in any case, you can just then share it to us and we'll diffuse it amongst the
Yes, I don't think we can
participants.
send files through the
Okay.
chat, but I don't know, we could upload it. I don't know if in LinkedIn you can upload. Otherwise, if you have channels to...
Yeah, of course, you can just share it with us and we will try to diffuse it.
Upload it in LinkedIn. Why not?
Okay, we can do both.
Yeah.
And then there's another question. Was there any mention of autonomous vehicles in Barcelona in this project? When will Barcelona be moving to all EVs? I think this is like a really open question, but in case you have the answer to that.
Well, we don't exactly talk about autonomous vehicles here. The other project that is proximity that I briefly mentioned, in this case, we are talking about connected tram. What we, at least in this type of projects, we are mostly focused on the part of the infrastructure. So we want to have intelligent infrastructure and intelligent city that is ideally connected with the vehicles. So, for example, in the other project, in the proximity project, we are focusing on a safety implementation, on a safety use case. So we want to detect hazards that take place in specific intersections where we have a lot of cars crossing, where the tram crosses. So there are specific hotspots in the city that are very dangerous. There are roundabouts with the tram passing, bicycle lanes, etc. So we want to be able to detect hazardous situations, for example, bicyclists crossing when the tram is approaching, or predicting the trajectory of two cars that are converging. So we want to be able to timely detect this type of hazards. And in the case of connected vehicles, we could foresee of transmitting this type of alerts to the connected vehicles in the area so they can modify their behavior. But if we want to truly talk about autonomous vehicles, then it's a different question, because you need to implement similar and more complex type of data analytics, because the connected cars also have, the autonomous cars also have the same type of pipeline. They have object detection, tracking, semantics, etc. But all this is implemented within the car because it needs to have very performance guarantees, it is very latency constrained, and it needs to pass all the certifications related to the automotive domain. So it's another story. But in BSc, we also have some projects about that, about developing software that can be reliable and can be executed within autonomous vehicles.
Well, that's amazing. I mean, I do not see any more questions. In case anyone wants to do any last question, go ahead. Otherwise, we will wrap up the session. Okay, no. So then thank you very much, Elli and Jan, for joining us. That was super interesting indeed, and very, very promising in the sense of it. I think it's super useful to have this type of project, more so in the city of Barcelona, as you said, one of the most polluted in Europe in the sense of NO2. And well, next episode will be on AI for low carbon cities. Will be moderated by Hubert, the founder of Urban AI. And in case you want to join, we will share the link on the chat so you can register. It's the same link as this episode. There you go. I just shared that on the chat, and I just hope to see you next episode then. Bye-bye, everyone.
Thanks a lot.
Thank you very much. And congratulations for the initiative.
Thank you. Bye-bye.
Bye-bye.
Bye.